Question 1. Matched pairs T procedure. A manager at a factory feels that the amount of time that his workers spend doing their part in the assembly line is too long. To determine if a new assembly procedure is effective in reducing the time, he measures the amount of time in minutes 9 of his workers take to complete 100 products. After implementing the new procedure, he again measures the amount of time in minutes the same 9 workers take to complete 100 products. And to obtain the following data, he wants to know if the mean assembly time is different and use the level of significance of 0.05. Use the link factory assemble times. So it says design the study. What is the research question? So he's trying to figure out
if his new device.
Yeah, if the new procedure is less than the old one. Okay.
The null and alternative hypothesis. So this one, they didn't give us like a number.
I don't think, a lot of it I don't know if you have to. I just think it's saying that it's not equal to 0.
Okay.
This one should be less than 0.
So the null would be equal to, and then the alternative would be not equal to?
Yeah. Okay. I'm going to pull up that stuff real quick.
Okay, my computer's trying to pull it up.
Gotcha. Which one's it called again?
It's the factory assembly time.
And we're 221B, so where you have to get... Yeah. Okay.
My computer just froze the document.
It what?
It just froze.
Excellent.
Yeah.
Love it when it does that. Okay, I think I've got it pulled up. Do you hear that sound?
Yeah.
That's our refrigerator.
Oh, good.
Yeah.
Love college apartments.
Yes. Sounds like it's like dying or something.
Okay, mine isn't gonna pull it up.
Okay. I'm just getting this stuff put in.
Okay.
I'm trying to remember how to do it. I'm looking at that. Okay.
I guess we can do number 2. Just says describe the data collection procedures. And so wouldn't there just be a what is it called? The placebo group? What is that called? Control group.
Yeah.
And then the
So just trying to see what the
you're fine.
yeah. So we have the okay. Sorry, it's being kind of okay. So we got the differences. I learned more how to do it on the Excel because I like better the Excel.
Yeah, that's what I'm trying to do, but for some reason my computer won't pull up Excel. It like won't register it.
Really?
Yeah.
I'm gonna do it in Excel because I think that's easier.
I really like that they let us use Excel now.
I know.
Instead of just SPSS.
Okay. I think I've got it. So keep pressing the wrong one. It gives you, we got the mean, the difference mean is negative 1.056.
Okay.
And then the sample, or the standard deviation is 2.596. The standard error of the mean is 0.865. The degrees of freedom are 8. And there's 9 samples.
Okay. So then the next one is just write a short paragraph and describing the statistics while summarizing. So you basically just did that.
Yeah. Yeah.
Sorry, I'm not like waving or anything. My dog's like attacking my arm. So
What's that?
I said I'm not waving.
Oh,
My dog's just attacking my arm. So
gotcha. In the answer key, it has D equaling 1.056. Um, and it says negative, so did I do something wrong? Because you're supposed to do the post minus the pre, right? That's what I thought. Okay. So let's just make a histogram of it. So got a histogram. Did it want us to make a Q and Q plot too?
no.
Okay. All right. So it says
So,
make. I think we got that one done, don't we?
yeah. It's basically like it's two-tailed because of the paired samples. And then are the requirements met for the test? I would assume so because it's a random sample.
Yeah. But the numbers are less than 30, aren't they?
Yeah.
So then we need to make the Q and Q plot to see how normal it is. Do you remember how to do the Q and Q plot on SPSS?
Don't you just go to explore and then there's like the graphs? It's like analyze, explore, graphs, or something.
There's transform, analyze. I know to do the histogram, you go to graphs and then legacy dialogues, and then it gives you bar, 3D line area, pi, high-low, box plot, error, population pyramid, scatter plot, and histogram.
Isn't the QQ plot the same as the scatter plot?
Oh, yeah.
Or that might just be me making it up.
So the x-axis, oh man, giving myself a little headache. That's the hardest thing at this class is remembering all the little things you have to do. Oh, it's under descriptive. There it is. It's under descriptive statistics.
Um,
And it is. It's not very normal looking. It's kind of all over the place.
but can you put like a line through it?
There's one. I don't know how to describe it. It kind of. It's like almost mirror images of each other. If you like almost to flip them, they look
Oh yeah.
similar. So it's like on the x-axis, -8, and like -1.7, then it goes all the way over to -2. But on the top, I don't know. It's hard to explain. It's not very normal.
Okay, so it would the answer would be no because it's not normally distributed.
Yeah, I guess, yeah.
The answer key doesn't really say yes or no.
Yeah, it just kind of tells you what to do. So I guess it would be no because it's not normal. The t-score. Okay, it's weird. The answer key says 1.22, but the output stuff says -1.22.
Maybe just like the equation was entered in wrong or
Yeah,
something.
maybe I did that wrong. I thought I did it right. It's post minus the pre. B2 minus A2. Well, that's good that it got it right, though. I mean, that was a problem we had last week, was that it wouldn't output the t-score right.
Last week was rough.
Yeah. How'd you do on the test last week?
There was a test last week.
Or the quiz, sorry.
It's like go up or go down. I did okay.
I missed 3.
Yeah, I think I missed like 4.
So the degrees of freedom on this one are 8.
Yeah.
Um,
And compute the p-value. Okay, I need to ask the teacher about p-value because I seriously don't understand it.
the answer for this one should be 0.257, but I think the p-value, they're confusing to me too. I think what it's saying, I think it has to do with like the probability of something being true or not. So I think that's why like we use it to reject the null and not to reject the null. I just typed it in Google and it says the p-value or calculated probability is the estimated probability of rejecting the null hypothesis of a study question when the hypothesis is true.
Okay.
Okay. P-value is greater than the level of significance, so we reject it. Oh, we fail to reject it, excuse me.
So anytime you fail to reject, you just put there's insufficient evidence.
Yeah, there's no evidence to say that we'd reject it. No, this is better than that.
Yeah. Okay, rather than testing a hypothesis, now say you just want to estimate the mean difference between wait time at a 95% level, what would you do? Well, you'd create a confidence interval.
Yeah.
Okay, next one.
Yeah.
Okay. In a short paragraph, describe the action you feel should be taken based on the statistical results above. So is that supposed to be like on what we did or like on the study?
In a short paragraph, describe the action you feel should be taken based on the statistical results.
It's on the study, then he just has to make his machine better.
Yeah, he's got to find a way to cut down time still.
Mm-hmm.
He's got to find a more efficient way. I don't know what he's making. Does it say what he's making?
Mm-hmm. No, it just said like a machine.
Yeah, so they just got to find a way to make it faster. Yeah, I don't know. Okay. That's it.
Yep. Now for the quiz.
Okay. Is that a sneeze? Okay, you ready? All right. Suppose we have a set paired data, suppose we have a set of paired data and let d equals x after and minus x before. The null hypothesis is the mean equals 0. The alternative hypothesis is the mean does not equal 0. And the population standard deviation is not known. Jordan collects a sample size of 9 and computes sample mean, or the mean to be 2.2, and the standard deviation to be 3.3.
What is the value of the test detector?
So this is the t-value they're looking for, right?
Mm-hmm.
Is this the formula we used last week?
Maybe.
It doesn't really give us the numbers for the 9 she collected. But then the standard deviation.
No, it says that d equal x after minus x before. So would it be that 2.2 equals, like, would that be 3.3 minus x before?
I don't think so, because isn't SD, isn't that?
That's a sample deviation.
Yeah.
I just, are like the only two numbers they gave us.
So because you could go, I just don't know what the other mean would be, because you could go 2.2 minus whatever the mean is, and then divide that by 3.3 divided by the square root of 9, and you get error. You get 2, I think. But I don't know. I just went 2.2 minus 0.
So you think it's 2?
I mean, that's what it has in the reading as far as it just says, yeah, from the example we did before, it was negative 6.8 minus 0.
Okay.
And then divide the standard deviation by the square root of n. So I guess we could go with 2. Hopefully that's right.
Okay. The probability of being greater than 1.0 is 0.0403. Use the alternative hypothesis to determine the p-value for this test.
How do you do the p-value without the
Z-star.
yeah, without the numbers to put into the Excel and stuff? Okay, yeah, there's a formula. What? Do you remember reading about how to find the p-value without the stuff?
I don't remember it. I know that it says.
Oh yeah. So
Okay, is the p-value the same as the probability?
yeah, it's that it's the calculated probability, estimated probability of rejecting the null hypothesis. Okay, I wonder if it's this formula. 0.0403 divided by 2. What?
Divided by the standard deviation over square root of n.
Because there's that problem we did in the reading. It's talking about the non-somacal comio infections, but I don't really understand that formula because it says p-value equals sig 2 tail divided by 2, which that equals 2.592 times 10 to the negative 7th divided by 2, and that equals 1.296 times 16 to the negative 7th. But I don't understand how what numbers ours have to be for that. The 0.0403, I wonder if that's supposed to be the probability.
For that formula that you gave me, I got 0.022165.
Which formula was that?
The 0.0403 divided by 2 divided by the the standard deviation divided by the square root of n.
I gave you that formula?
Well, I just added it in for the standard deviation. I remember seeing that in the reading.
Probability of being greater than. I have an idea. I wonder, because in the question it says that the probability of being greater than 0.0403, or than 2 is 0.0403. But the alternative hypothesis is just saying that it's not. Oh, crap, never mind. I thought I was on to something. I was wondering if we did less than 2 as well, but I don't think that would work either. I'm super confused.
I'm trying to find the reading.
Yeah, I have no idea. The only thing I see about how to, like, a formula to use is that one, but I don't know where they're getting those numbers. What, 0.0403 divided by 2?
I think that. I think that 2 is the z-score, and then the 0.043 is the probability.
I'm wondering if it's saying on this formula if it's two-tailed, then you divide it by 2.
You divide the probability by 2?
So we take that number and divide it by 2.
I do remember last time when I took this class that I had to do that somewhere.
You what?
So I remember last time, like when I took this class, this is like kind of near the beginning of the semester, and I remember having to read about this.
Oh, really?
Before I dropped out.
Well, I'm going to put that number. I'm going to put 0.020 for now. Unless I can think of something else.
Yeah. Sounds like fun.
Alright, we'll do it that one for now. Use the data listed below to answer questions 5 through 10. Copy and paste the data into an appropriate software and make a column of differences. Use a null hypothesis, an alternative hypothesis, and level significance of 0.10.
See if I can open up Excel again.
I'm trying to copy and paste it, but it like keeps highlighting the whole page. Okay. Okay. What is the mean? Oh, the phone. Gotta put it in the other category now.
So the degrees of freedom are 39, but it doesn't ask for that.
What's that?
We said the degree of freedom is 39, but it doesn't ask for that, so...
Okay, so the mean of the difference, is that what you were doing?
What what is, yeah, the differences.
It is negative 31.025. But I wonder if do we write that just as 31.025?
Yeah, I think so.
Standard deviation is, wow, that's crazy. It says it's 341.157. That's crazy.
Okay, how do you do it in Excel?
So you gotta open up like an Excel sheet. And then you've got to put one column in one and then the column in the other. Then you're supposed to. Then you create a column, a third column, which is the differences, which is the post minus the pre. That's a big standard deviation. Oh. And this has a test. The t value is negative 0.407, so it would be 0.407.
Yeah.
And the p-value is 0.689. So we fail to reject the null.
And suppose your alternative hypothesis is greater than 0, then what is the correct decision based on this evidence?
It'd still be fail to reject. I'm worried about this quiz. Hope we're doing it right.
Okay. Use the data listed below to answer questions 11 to 16. Copy and paste the data into the appropriate software and make a column of differences. This data comes from NASM. The null hypothesis is equal to 0.
Well, let me put the formula in, at least for the first one.
I'm still trying to copy and paste it.
There we go. Okay. You get them in there?
For some reason, it won't let me paste them.
Well, number 11's pretty simple. It's N.
So just so I know, when you get them pasted in, what do you do?
Oh, say that again.
Just so I know, when you get them pasted into Excel, then what do you do?
When you get the numbers done,
Mm-hmm.
you've got to open up. There's a link in the reading to the quantitative inference procedures page of Excel.
Okay.
And when you open that up, it has a couple different things. That's what we use for the one sample t-test, and this one has a paired sample t-test. And there's a couple of them on the bottom. And so you just have to click on the paired sample, and then you copy the data that you put in, so the variable 1, variable 2, and then the difference. You copy and paste that into the box, and then it just gives you all the information you need.
Okay.
The p-value that it gives me is 0.001.
So then we would reject the null hypothesis.
Yeah.
Okay. You decide to try another alternative hypothesis. This time you use the alternative is greater than 0, and you keep the same level of significance. Does the p-value increase or decrease?
It increases on here.
Increases.
That one we would fail to reject.
Mm-hmm. Okay, as we've seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value? So then would it be it's less than 0?
On this one it is. I've been paying too much attention to see what the other ones are.
Mm-hmm.
I mean, it could depend on the problem too. Which one are you feeling?
Well, I'm thinking that for this last one, like when it's equal to, it was small, and then when it got, like when it was greater than, it was bigger.
Mm-hmm.
So I'm thinking that when it's less than, it will be small.
So we go with that one then.
I'm scared.
Oh, this one was a lot harder than I thought it was going to be.
Well, C5. Oh,
Yeah.
that 341 was right.
Oh, really?
Yeah.
What did we get? We got a C+.
Yeah, we got the last 3 wrong. And then number 4, you got right? I mean,
How did we get the other one wrong? I typed it in.
eating something. What?
How did we get the last 4 wrong? Because I put it in that stupid thing.
So it would decrease, and then you would reject the null hypothesis. And then it's not enough information. Depends on the problem.
That's stupid. Yeah, I don't know how to do number 4. That's lame though. I don't know why it would decrease. It doesn't make sense. Alright, well, I guess we'll see you Thursday.
Yep, it's 7:30.
Sounds good. I might not be here, but Cambria should.
Okay. Bye.
Alright, see ya.